What if I told you that everything you thought you knew about the universe might be wrong? The James Webb Space Telescope has seen something so unexpected, so impossible, that scientists are whispering words they never thought they'd say. Physics might not work the way we believed. Stay with me and don't forget to subscribe, because tonight you're going to fall asleep to the story of how the universe just broke its own rules. So, let's start slowly. Picture yourself lying under a night sky, the stars scattered like diamonds on black velvet. For thousands of years, humans looked up, wondering what was out there. We built myths, we built stories, we built science, and now we've built something far more powerful, the James Webb Space Telescope, a machine that can peer back in time itself to the very first galaxies that ever existed. But here's the problem. What Webb has seen doesn't make sense. It's like walking into a library where all the books are written before the alphabet was invented. Galaxies that are too big, too old, too bright, too soon. The universe is supposed to take billions of years to build such grand structures. Yet Webb has found them almost instantly after the Big Bang. Imagine watching a baby being born and finding out that somehow the baby is already a teenager. That's the kind of puzzle James Webb has dropped in our laps. Let's drift into the story gently. The telescope itself is a wonder, the size of a tennis court, with a mirror plated in pure gold, orbiting nearly 1,000,000 miles from Earth. It sees in infrared, meaning it can capture heat, light, stretch the thing by billions of years of travel. In other words, Webb doesn't just look at stars, it looks through time itself. And here's the strange part. What it saw when it first opened its golden eyes wasn't just breathtaking, it was impossible. Some galaxies appeared so soon after the Big Bang that our current physics, our textbooks, our models, even Einstein's equations struggle to explain them. Scientists have started calling them impossible galaxies. They are too massive, too structured, too well formed to exist so early. Think about that for a moment. The entire framework of modern cosmology, the Big Bang, the growth of stars, the birth of galaxies has been shaken. So, let's take a slow walk through this mystery. Tonight, as you let your eyes close, I'll guide you through the secrets Webb is uncovering. The story of impossible galaxies, strange physics, and a universe that may be far stranger than we ever dare to imagine. Breathe in and imagine yourself floating just beyond the telescope, staring into infinity. You'll see what Webb sees. And maybe, just maybe, you start to wonder, what if the laws of physics are not laws at all, but only guesses? And that's where the story begins. Before we talk about what Webb discovered, we need to understand why it exists at all. For decades, astronomers dreamed of a telescope that could do what Hubble couldn't. Hubble, our beloved eye in the sky, gave us breathtaking views of the cosmos. But Hubble sees mostly invisible light, the light our eyes see. Webb, however, was built to look deeper, beyond the rainbow of colors our eyes can detect, into the invisible glow of infrared. Why infrared? Because the universe is old and light stretches as it travels. Imagine sound echoing in a canyon. The further it bounces, the deeper and softer it gets. Light does the same thing. The oldest galaxies, born billions of years ago, have their light stretched so far across time that it's no longer visible, it slips into the infrared spectrum. If you want to see the very beginning, you need to see in infrared, and that is Webb's superpower. Webb wasn't just a telescope, it was a time machine. It was humanity's attempt to look back almost 13.5 billion years to witness the first sparks of creation after the Big Bang. Scientists expected to see faint, tiny, chaotic clusters of stars. The early universe was supposed to be messy, like the scribbles of a child before they learn how to write properly. Galaxies were supposed to take hundreds of millions of years to stabilize into graceful spirals and gyres. But when Webb opened its golden honeycomb mirrors and focused on those first patches of sky, what it revealed was unsettling. Instead of fragile, baby galaxies, it saw massive, mature structures. Galaxies bigger than our own Milky Way, sitting there calmly shining less than a few 100 million years after the universe itself began. Let that sink in. According to our current physics, this shouldn't be possible. The laws of gravity, the speed of star formation, the amount of available matter, it all says galaxies shouldn't grow that fast. And yet, Webb saw them. It's like planting a seed in the soil and coming back the next morning to find a fully grown oak tree, branches spreading wide, roots sunk deep, casting shade. Every scientific model we had said that was impossible. And yet, Webb was showing us an oak tree where we expected only a fragile sprout. Some scientists quietly panicked. Others grew excited. Because when nature breaks your rules, it means there's something you don't yet understand. One astronomer described the discovery like this. It's as if the universe is laughing at us, saying, "You thought you knew me? Not even close. Let's pause here and imagine. You are floating just beside Webb, 1,000,000 miles from Earth, shielded by its massive sunshade. Below you, the Earth glows faintly blue. Ahead of you, infinity. And Webb's golden mirrors reflect faint starlight, gathering whispers of the ancient universe. Those photons, tiny packets of light, left their galaxies billions of years ago, long before Earth even existed. And now, after traveling across all of time and space, they strike Webb's sensors and reveal a truth we weren't ready for. Webb was built to confirm our theories. Instead, it shattered them. Because these impossible galaxies suggest one of two things. Either galaxies form much faster than we ever believed, or our understanding of physics itself, the rules of time, gravity, and matter, needs rewriting. And rewriting physics is no small thing. It's like finding out the foundation of your house is made of sand, not stone. If the basics are wrong, everything built on top begins to wobble. So now, scientists are scrambling for answers. Some suggest dark matter, the invisible glue of the universe, may behave differently than we thought. Others whisper about exotic physics, ideas that would rewrite the very first moments of the cosmos. A few even wonder if our timeline of the Big Bang itself is flawed. The James Webb Space Telescope, designed to answer questions, has instead left us with bigger, stranger ones. And that, my friend, is why so many scientists lie awake at night, staring at the ceiling, asking, what if everything we thought we knew about the beginning was wrong? Imagine looking into a mirror that doesn't just reflect your face, but reflects time itself, stretching billions of years into the past. That's what the James Webb Space Telescope does every single day. Each image it captures isn't just a pretty picture of stars and galaxies. It's a time capsule. It's the universe whispering its secrets from when it was young, fragile, and just beginning to take shape. Now, here's where things start to get really strange. The Webb Telescope recently picked up galaxies so ancient, so far away, that they shouldn't even exist by our current understanding of physics. These galaxies appear to be far too developed, too mature for the short amount of time that had passed after the Big Bang. By the rules we thought we knew, they simply shouldn't be there. And yet, Webb saw them. Picture this: a galaxy filled with billions of stars, swirling in graceful spirals, already formed less than a few 100 million years after the universe was born. That's like walking into a nursery and finding a fully grown adult sitting in the crib. It just doesn't fit the story we've been told. Scientists thought galaxies took billions of years to slowly form, like delicate sandcastles built grain by grain on a quiet beach. But Webb's images suggest the universe built entire cities of stars at lightning speed, faster than our equations can explain. And that's why some researchers say James Webb has shattered physics. It's not that physics itself is broken, it's that our story of the universe might be incomplete. As you listen, try to imagine drifting through one of those early galaxies. Stars flickering like campfires scattered across a cosmic desert. Some so massive they burn out in just a few million years, exploding in brilliant supernovae that light up the darkness. The Webb Telescope is catching the glow of those very first stars, whispers from an age we thought was unreachable. And here's the question that keeps cosmologists awake at night. If these galaxies formed too early, what does that mean about the timeline of the Big Bang? Did we miss something? Was the universe able to create matter and structure much faster than we thought? Or could it mean something even more unsettling, that our understanding of time itself might be incomplete? The more Webb sees, the more the puzzle grows. It's like peeling back the layers of an onion, only to realize that instead of finding the core, you discover endless more layers, each stranger than the last. Close your eyes for a moment and picture those deep Webb images. Thousands of galaxies scattered across the black canvas of space, each one holding hundreds of billions of stars, planets, and maybe even life. And remember, that's just one snapshot, just a single pinhole glance into the sky. Imagine how many more lie beyond, unseen, untouched, waiting for us to discover. And as you drift with that thought, ask yourself, if our physics can't explain what Webb has found so far, what else is waiting to be uncovered? When you look at a picture from the James Webb Telescope, you're not just seeing stars and galaxies. You're also seeing something invisible, something hidden in plain sight. Because between those brilliant bursts of light, there is silence. A silence made of something we cannot touch, cannot see, and cannot fully explain. Scientists call it dark matter. Think about this. If you picked up a book and half the pages were missing, would you still understand the story? Maybe, but it would never make sense completely. That's how our universe works. Every galaxy, every star, every planet you've ever heard of only makes up about 5% of everything that exists. The rest 95% is invisible, dark matter, dark energy. Unknown forces that Webb is quietly mapping, like shadows dancing just outside the glow of a campfire. Dark matter acts like scaffolding. It doesn't shine, it doesn't glow, but it holds galaxies together, keeping their stars from flying apart into the void. Without it, the universe would look very different, chaotic, unstable, like sand slipping through your fingers. When Webb peers deep into the cosmos, it doesn't just see the galaxies. It sees how they bend light, how they curve space itself, revealing the fingerprints of this invisible matter. Close your eyes and picture this. A massive cluster of galaxies floating in the black. Behind them, light from even more distant galaxies bends around, warped and stretched, like light shining through a droplet of water. This bending, this cosmic lensing, is how we know the invisible scaffolding exists. Webb is not just taking pictures, it's revealing the skeleton of the universe. And then there's dark energy. If dark matter holds the universe together, dark energy is tearing it apart. It's the reason galaxies are not just moving away from each other, but speeding up, accelerating like cars on a highway with no brake. Scientists once thought gravity would slow everything down, that maybe, one day, the universe would collapse back in on itself. But Webb's deep surveys remind us the opposite is true. The universe is expanding faster and faster, stretching the very fabric of reality like a balloon being blown bigger and bigger. Here's the part that might keep you awake tonight. Even as you drift off, we don't know what dark energy island, we don't know why it exists. It makes up most of everything we know, and yet it remains a mystery. Webb is giving us clues, but clues only make the puzzle more confusing. Imagine a giant cosmic clock ticking steadily in the background of existence. For billions of years, we thought we understood how it worked, second by second, star by star. But now, James Webb is showing us that the clock has hidden gears, invisible springs, and perhaps even secrets that don't follow the rules we thought were unbreakable. And maybe that's the beauty of it. The universe doesn't owe us easy answers. Sometimes it whispers mysteries instead. And Webb, floating far from Earth, shielded from the noise of our planet, is listening. As you sink deeper into thought, ask yourself, what if dark matter and dark energy are just names for something bigger, something we cannot yet imagine? What if the laws of physics we've built our world upon are only the beginning of a much larger story? Time. We live inside it every moment, yet we rarely question it. The clock ticks, the sun rises, the seasons change, and we accept it as natural. But the James Webb Space Telescope has shown us that time, cosmic time, might not behave the way we thought it did. When astronomers first turned Webb toward the most distant edges of the universe, they expected to see young, chaotic galaxies, small, messy, still forming stars like embers just beginning to glow. After all, if you look back far enough, You should see the universe in its infancy. But instead, Webb revealed something that shocked the scientific world. Massive galaxies, fully formed, some as large and organized as the Milky Way, existing less than 1 billion years after the Big Bang. That's like finding a grown tree in a forest where the seeds were only planted yesterday. For decades, physics has given us a timeline. First came the Big Bang, then a period of darkness. Then the first stars flickered to life, followed slowly by galaxies taking shape. But Webb's images suggest that either galaxies formed much faster than anyone believed possible, or that our understanding of time itself needs rewriting. Imagine walking into a museum where every painting is arranged in order, from the oldest to the newest. You stroll down the gallery, and the story makes sense, until suddenly, halfway down, you find a painting that shouldn't be there. A masterpiece that looks like it belongs centuries later. That's what Webb is doing. It's rearranging the gallery of the universe. And with that rearrangement comes a haunting question. What if our cosmic clock is wrong? Time might not flow as smoothly and universally as we assume. Einstein taught us that time bends, stretches, and slows depending on gravity and speed. Perhaps in the early universe, time itself behaved differently, thicker, denser, more fluid than it is now. Maybe galaxies had more time to grow than our equations suggest. Or maybe time is not as linear as we think. Close your eyes and picture it. Billions of stars blooming far too soon, like flowers blooming in winter, defying the rhythm of the seasons. That's what Webb has shown us, an orchestra of galaxies playing out of tune with the sheet music we thought the universe was following. Some scientists whisper about the possibility of new physics, laws not yet discovered, rules that could explain how everything seemed to move so quickly. Others wonder if the very age of the universe could be miscalculated, that perhaps the cosmic calendar needs to be rewritten. Whatever the truth is, one thing is certain. Webb has shattered our comfortable sense of time. It has reminded us that the universe is not a clock we can easily wind or predict. It is a mystery, one where time itself may bend in ways we cannot yet imagine. And as you drift deeper into this thought, let your mind rest on a quiet idea. Maybe time, like space, is far more flexible, far more mysterious than we could ever grasp while sitting here on Earth. Perhaps time is not a straight line at all, but a river that twists and turns, carving secret paths through the cosmos. Light. We see it every day, and so often we take it for granted. The glow of a lamp, the warmth of the Sunday, the faint shimmer of stars above us. But in truth, light is the oldest storyteller in existence. It carries messages across unimaginable distances, whispering secrets of the past to whoever knows how to listen. And James Webb is the greatest listener humanity has ever built. When Webb looks out into the universe, it isn't just snapping pictures. It's catching light that has been traveling for billions of years. Some of the photons it sees left their stars long before Earth was even born, before our sun was even a spark. Those little packets of energy crossed space, dodged galaxies, brushed past black holes, and finally arrived at Webb's golden mirrors, waiting patiently in the cold silence of space. Imagine a bottle tossed into an ocean. Inside is a note written eons ago. The bottle drifts for ages, carried by currents, passing storms and waves, until at last it washes ashore. That's what light is like. Every beam Webb captures is a message in a bottle, written by the universe itself billions of years ago. But here's the twist. This ancient light doesn't look the same when it reaches us. Because the universe is expanding, the light gets stretched, pulled into longer and longer wavelengths. This is called redshift. What once was brilliant blue or white becomes stretched into the deep infrared light, invisible to our eyes. That's why Webb was built to see the invisible. Its instruments can read this ancient, stretched light like a language no human eye could ever hope to understand. Picture it. A star shining bright, its light racing outward. With every billion years that pass, the universe stretches that light further and further, until only Webb, floating in its perfect perch beyond the Earth, can see it. To us, it's invisible. To Webb, it's a glowing trail that leads straight back to the dawn of time. And in that light are secrets, the fingerprints of atoms, the birth cries of stars, the smoke trails of galaxies forming out of dust. Webb isn't just showing us pictures, it's decoding the universe's diary. But here's what makes it even more haunting. Light doesn't just tell us where things are. It tells us where things were. The galaxies Webb reveals may no longer exist as we see them. They may have merged, changed, or even vanished. Yet their light, their ancient stories, are only now arriving. It means that when we look at the sky, we're not seeing the universe as an island. We're seeing the universe as it was, always living in the past. Think about that for a moment. Every star above you is a time capsule. The light of the nearest star took years to arrive. The light from some galaxies took billions. To gaze into the night sky is to stare backward into memories written by fire. And Webb has opened a window into the deepest memories of all. It sees farther, older, fainter than any telescope before it. It sees light from the first stars, the first galaxies, the first moments when darkness gave way to illumination. So as you close your eyes, let that image rest in your mind. Photons, tiny messengers, drifting through endless darkness for billions of years, only to land softly, quietly on golden mirrors. And with that landing, humanity gets a glimpse into the forgotten past of the universe. Light, the first storyteller, the last witness, and the bridge between us and the beginning of everything. Black holes. The phrase alone feels like a whisper, doesn't it? Something dark, something final, a place where even light itself surrenders. And yet, Webb looks toward them too. At the heart of nearly every galaxy we've studied lies a monster, a black hole so massive it bends the very fabric of reality. Some of them weigh millions of times more than our Sunday, others billions. They sit in the center like beating hearts, invisible yet in control, pulling stars and dust into swirling, hypnotic spirals. But here's the paradox. Black holes don't let light escape. So how does Webb see them? It doesn't look at the holes directly. Instead, it studies their surroundings, the way stars whip around them, the glow of matter as it heats up, moments before it vanishes into the abyss. Like watching ripples on water, Webb can trace the shape of something we cannot see. Imagine standing in a dark room. You can't see the fan spinning above you, but you can hear the air moving. You can feel the currents brushing your skin. That's how Webb listens to black holes. It doesn't need to see the monster to know it's there. And sometimes what he sees is beyond eerie. There are quasars, distant beacons powered by supermassive black holes. They shine so brightly that they outshine entire galaxies, yet at their core is absolute darkness. Webb can peer across billions of years to study them, these cosmic lighthouses flickering at the edge of time. Some of that light has traveled to us since the universe was only a few 100 million years old. Quasars shouldn't even exist that early, and yet Webb finds them glowing defiantly against the void. But here's what keeps scientists awake at night. Black holes grow far too quickly. According to what we thought we knew, there hasn't been enough time for them to reach such colossal sizes. Yet Webb keeps spotting them, ancient giants, sitting where they shouldn't be. It's as if the universe skipped a few steps, or as if some hidden rule of physics is quietly at play. Think about that. These objects are so powerful they erase light, they twist time, they break our math, and still, Webb sees their fingerprints scattered across the cosmos. Now, pause here and picture it. A galaxy spinning gracefully in the dark, stars glittering like jewels. But in its center, a whirlpool of shadows, quiet, patient, waiting. Matter spirals inward like leaves down a drain. And in those final moments, just before everything is swallowed, it shines brighter than 1,000 suns. Webb sees that moment. The last cry of light before silence. Some even wonder, could black holes be more than just endings? Could they be beginnings? Could they connect different places, different times, different universes? No one knows. But every image Webb sends back nudges us closer to questions we never thought to ask. So as you drift deeper into rest, let your mind wander. Imagine floating at the edge of one of these giants, not falling, not fighting, just suspended. You'd see stars stretched and warped, light curving into impossible shapes. Time itself would slow until seconds became lifetimes. And there, in that quiet, you'd feel the weight of eternity pressing all around you. And yet, somehow it's peaceful. Because even in the heart of such darkness, the universe still speaks. Webb listens. And we dream. There are moments when Webb turns its gaze to the farthest edges of the cosmos, and what it finds feels almost like a trick of the eye. Because out there, in places where the universe should still be a newborn, messy, chaotic, unformed, Webb sees galaxies that are perfect, fully shaped, massive, bright, too massive, too bright, too soon. These galaxies shouldn't be there, not yet. According to everything we thought we knew, the early universe was supposed to be clumpy and small. stars forming in scattered clouds, tiny proto-galaxies struggling to take shape. But Webb has spotted galaxies so large, so organized, that they seem to have skipped billions of years of cosmic growth. It's like walking into a nursery and finding not newborns, but full-grown adults standing there smiling back at you. Scientists call them impossible galaxies. Some of them are as old as 13 billion years, forming just a few 100 million years after the Big Bang. And yet, they look like galaxies we see much later in the universe's history, spiral structures heavy with stars, glowing with complexity. This discovery rattled the field of physics. Because if these galaxies are real, and Webb keeps confirming that they are, it means our timelines are wrong. Our models of how quickly matter clumps together, how fast stars are born, how galaxies evolve, they may all need rewriting. But here's the soothing thought. This isn't the universe breaking. It's the universe surprising us. It's reminding us that we are still learning, still peeking behind the curtain of something far greater than ourselves. Picture this with me. Floating gently in space, you look out across the void. The light Webb is seeing has traveled for billions of years to reach us, carrying stories of the first stars, the first galaxies, the first sparks of order. And instead of chaos, instead of fragments, you see glowing cities of stars, spirals, clusters, massive islands of light already in place, defying what we thought possible. Maybe the laws of physics are more flexible than we imagined. Maybe gravity works differently at the dawn of time. Or maybe, just maybe, there are forces we haven't even begun to name. And here's something stranger still. Some of these galaxies are so dense, so tightly packed with stars, that they feel almost artificial. Of course, the scientists don't say that. But in the quiet hours, imaginations wonder. If life were ever to rise in such galaxies, in such crowded neighborhoods of stars, the night skies would glow like a cosmic lantern, thousands of suns lighting up every horizon. What would a world like that look like? Would sleep even exist in such places, with so much light raining down? Or would civilizations grow accustomed to a sky ablaze? We don't know. But Webb keeps finding these anomalies. Galaxies that rewrite the rules, galaxies that shouldn't yet shine, galaxies that feel like whispers from a past we never expected. So as you relax now, let that thought linger. The universe is not static. It's alive. It surprises. And sometimes the surprises are beautiful. Close your eyes and imagine drifting toward one of those ancient galaxies, its spiral arms stretched out like open hands, welcoming you in. Stars pulsing softly, like heartbeats in the dark. And as you glide closer, you realize this light has been waiting for you. For billions of years, it has traveled across time itself just to touch your eyes tonight. And in that moment, the impossible feels possible. Out there, far beyond the galaxies that Webb has revealed, lies something we can't quite see, something that doesn't glow, doesn't shine, doesn't reflect, but it's there, holding everything in place. It's called dark matter. Without it, galaxies would simply fly apart. The stars would scatter like dust in the wind, drifting away into emptiness. And yet, When astronomers measure the spin of galaxies, they find something strange. The stars are moving so fast, the galaxies should be tearing themselves apart, but they don't. Something invisible is holding them together, like an invisible net, a hidden skeleton made not of bone but of mystery. That something is dark matter. It makes up about 27% of the universe, and yet we've never touched it, never seen it directly. Webb doesn't see dark matter either, but it does see the effects, the way galaxies bend light, the way invisible mass pulls and stretches the fabric of space. And then there's something even stranger. If dark matter is the glue, dark energy is the opposite. It's the force that pulls the universe apart, pushing galaxies away from one another faster and faster, as if the cosmos itself is breathing out, expanding into the silent. Scientists believe dark energy makes up nearly 70% of everything, which means almost all of the universe is made of things we can't see, can't hold, and barely understand. And yet, here we are, floating in the sliver of the universe that glows just 5%. The stars, the planets, the galaxies, even us, all of it, just the tip of the iceberg. Now, close your eyes and imagine drifting in a galaxy Webb has captured. You see the stars, yes. You see the glowing clouds of gas, yes. But wrapped around it, unseen, is a halo of dark matter, vast and silent, like a guardian no one can see. It cradles the galaxy, holds it in place, makes sure the stars do not drift into the void. It's almost comforting in a strange way. The universe has its own hidden scaffolding, keeping everything together, even when we don't notice. But then you feel the other pull, the expansion, the quiet stretch of space itself. Galaxies not just drifting, but rushing away, carried by the current of dark energy. The night sky isn't static, it's changing, stretching, like paint being pulled across an endless canvas. Here's the problem. Dark matter and dark energy don't play by our rules. They don't fit neatly into the boxes of physics. They don't behave the way matter and energy are supposed to. They are both everywhere and nowhere. Some scientists whisper that maybe we've misunderstood gravity itself. Maybe the universe is telling us, your rules don't apply here. Others suggest it could be something even more radical, hidden dimensions, particles we've never imagined, or even echoes of universes beyond our own. For now, Webb gives us glimpses, galaxies distorted by invisible halos of dark matter, patterns in cosmic light that suggest the push of dark energy. But it doesn't solve the puzzle, it only makes the questions deep. And maybe that's the point. Because sometimes mystery is what keeps us awake at night, staring at the stars. And sometimes mystery is what lulls us to sleep, reminding us that not everything needs an answer. Some things are simply there, quiet, steady, watching. So, as you breathe slow and calm, imagine lying back in the cradle of the universe, held by the unseen hands of dark matter, carried forward by the silent push of dark energy. A universe that is both known and unknown, visible and invisible. And maybe that's why it feels so alive. There's a quiet question that lingers behind almost every mission NASA has ever launched into space. It's not written on the rockets, not carved into the side of telescopes, but it's there, a whisper in the back of humanity's mind. Are we alone? The James Webb Space Telescope was not just built to look at distant galaxies. It was also built to search for life. Not by pointing a giant camera at another planet and hoping to see an alien waving back, but by doing something subtler, something almost poetic. Webb listens to the atmospheres of distant worlds. When an exoplanet, one of those countless planets orbiting stars beyond our sun, passes in front of its star, a tiny sliver of starlight filters through its atmosphere. To our eyes, it's nothing, just a faint dip in brightness. But to Webb's instruments, it's a treasure. That light carries fingerprints, chemical signatures written in invisible ink. By stretching the light into its spectrum, Webb can see which gases are there. Oxygen, methane, carbon dioxide, water vapor, and here's the magical part. Those gases, especially in the right balance, can mean life. On Earth, oxygen doesn't just appear on its own. It's made constantly by life, by plants, by plankton, by everything that breathes. Methane too, our own cows, swamps, and even humans created. So, if Webb finds a planet with both oxygen and methane together, it's not proof, but it's a whisper, a suggestion, a cosmic wink saying, maybe. And already, Webb has delivered surprises. It has sniffed the atmospheres of worlds dozens of light years away and found water vapor drifting in alien skies. Imagine that for a moment. Clouds forming, rain falling, maybe even oceans glimmering under another Sunday. One world, called Ctu-18b, has shown hints of something stranger, a molecule called dimethyl sulfide, which on Earth is only produced by life. Scientists are cautious. Of course, it could be noise or something else we don't yet understand. But even a hint is enough to make the mind race. Now, imagine closing your eyes and drifting toward such a world. A place lit not by our sun, but by a faint, distant star glowing red. You float above its atmosphere, Webb's gaze tracing the gases in the air. The wind whispers with alien currents. The sky shimmers in colors we've never seen. What would life look like there? Not green plants, maybe. Perhaps not even animals. Maybe something stranger. Creatures that glow faintly in the dark. Vast fields of crystalline growths instead of forests. Life that doesn't breathe oxygen, but something entirely unknown. And here's the challenge. How do we recognize life when it might not look like us at all? That's the puzzle scientists face. Webb gives us the data, the chemical fingerprints, the shadows of alien worlds, but the interpretation is ours. Do we call methane a sign of life, or just geology? Do we assume water always means oceans, or could it mean something else? And underneath it all lies the most haunting thought. What if Webb does find it? What if tomorrow NASA holds a press conference and says, "We found signs of life, not little green men, not radio signals, just chemistry, a breath, a whisper, but still the first evidence that we are not alone." Would it terrify us? Would it comfort us? Or would it simply remind us of how small and yet how connected we truly are? For now, Webb keeps watching, gathering, listening. A patient eye turned not just toward galaxies, but toward the possibility that somewhere out there, another world breathes. So tonight, as you drift deeper into rest, picture those faraway planets, some rocky, some gaseous, some frozen, some burning. But within that endless diversity, maybe one world carries something familiar, a rhythm, a pulse, a heartbeat that isn't ours. And maybe, just maybe, that heartbeat is waiting for us to notice. There are moments when science doesn't just give us answers, it throws the table upside down and leaves us staring, wide-eyed, wondering if everything we thought we knew was wrong. That's exactly what the James Webb Telescope has done. You see, when Webb first started taking its deep field images, astronomers expected to see galaxies forming just a few 100 million years after the Big Bang. Tiny, faint, messy little clumps of stars, the beginnings of something larger. That was the prediction. That was the story in every textbook. But Webb didn't find that. Instead, it saw fully formed galaxies, huge, bright, spiral-like shapes shining in the cosmic dawn, billions of years earlier than they were supposed to exist. Imagine expecting to find toddlers just learning to walk, but instead discovering fully grown adults standing there staring back at you. This was not a small adjustment. This wasn't a, we got the math slightly wrong. This was a cosmic contradiction, a punch to the gut of modern physics and cosmology. Some scientists even whispered, "Are we wrong about the Big Bang?" Now, to be clear, the Big Bang theory still stands strong. But these galaxies, Webb is seeing some of them existed only 300 million years after the beginning, and they shouldn't have been there. They were too massive, too complex, too bright, like skyscrapers appearing in a village that was supposed to be made of tents. The problem deepens when you consider dark matter. Galaxies grow by pulling in dark matter, that invisible scaffolding of the cosmos. But these early galaxies seemed to have formed faster than dark matter could reasonably clump. That shouldn't be possible. So, what does that mean? Are the laws of physics we rely on incomplete? Are we missing something about the way the universe evolved? Or, here's the chilling thought, are we looking at something entirely different, something not accounted for at all? And that's not the only mystery Webb has shaken loose. In its images, Webb has captured giant structures, threads and walls of galaxies stretching for billions of light years. These cosmic webs aren't new discoveries, but the level of detail Webb shows makes them feel alive. The universe itself seems to have veins, arteries, a skeleton made of galaxies. And then there's the strange alignment problem. Some distant galaxies Webb has imaged appear to be lined up in ways that seem too neat, too precise, almost as if there's a hidden order to the chaos. Is it coincidence? An illusion? Or could the structure of the universe itself have some hidden geometry we don't yet understand? There's another puzzle too, black holes. Webb has spotted supermassive black holes in those early galaxies. Not baby black holes, not star-sized ones, but monsters weighing millions, even billions of times more than our Sunday. And they were already there, just a few 100 million years after the Big Bang. That shouldn't be possible. Black holes are supposed to grow slowly, by eating stars and dust over billions of years. But these ones, it's as if they skipped the line, as if they were born massive, fully formed. Some scientists whisper a phrase that sounds like science fiction, but is now creeping into real discussions. Primordial black holes. Black holes that formed not from stars, but directly from the fabric of the early universe itself. If that's true, it could change everything from the way galaxies form to the nature of dark matter. And here's the part that unsettles even the calmest mind. Every time Webb points somewhere new, it seems to find something that shouldn't exist. A star too massive, a galaxy too old, a cluster too organized. It's like walking into a library where the books are all out of order, some already finished before the story even began. For decades, physics has given us a sense of certainty, rules, laws, predictions that worked. And now, Webb is showing us cracks in that certainty. The foundations don't feel as solid anymore. So here's the question that keeps scientists awake at night. Are we witnessing the limits of human understanding? Or are we on the edge of the greatest scientific revolution since Einstein rewrote the laws of space and time? For now, Webb keeps watching. Patient, silent, unblinking. Every new image is both a gift and a riddle. A reminder that the universe is not obliged to make sense to us. And as you let your mind drift tonight, think about those impossible galaxies, those colossal black holes, that strange order hidden in the chaos. They may look like beautiful pictures on your screen, but to the people studying them, they're questions. Questions that could one day rewrite everything we thought we knew about the cosmos. And isn't that the most thrilling and terrifying part of all? There's a moment when the James Webb Space Telescope sends back an image that makes scientists go quiet. And it's not the kind of silence that comes from awe. It's the kind of silence that comes from disbelief. Imagine being a physicist who spent decades building models, equations, theories, only to see a single photograph that doesn't fit. That's what happened when Webb looked deep into the earliest galaxies. These galaxies shouldn't exist. They're too big, too bright, too structured. Like finding a fully grown oak tree in a forest where only seedlings should exist. According to everything we thought we knew, galaxies this massive couldn't have formed so quickly after the Big Bang. But Webb doesn't lie. The light is there. The galaxies are real. And that's when the whispers started. Did the Big Bang really happen the way we think? Are we missing an entire chapter of cosmic history? Is physics broken? Some scientists now believe we may need an entirely new theory of the universe, one that doesn't just tweak the rules, but rewrites them. And it doesn't stop with galaxies. Webb has spotted black holes so enormous, so early in the universe, that it almost feels impossible. These are not the kind of black holes that slowly grow from collapsed stars. These are giants, billions of times the mass of our sun, sitting in place less than 1 billion years after creation. It's as if they were there from the very beginning, waiting. What does that mean? Were black holes part of the blueprint of the universe itself? Are they the engines driving creation, instead of the monsters that consume it? And then there's the strangest discovery of all. Webb has begun detecting patterns in the way galaxies cluster together across unimaginable distances. These patterns don't look random. They look organized, as though the universe itself is following instructions we can't yet read. It raises a question so bold, so unsettling, that even scientists hesitate to speak it out loud. What if the universe is not just matter and energy? What if it has structure, intention, maybe even design? Now, I'm not saying we're living in a simulation. I'm not saying there's a hidden architect behind the curtain. But I am saying this. The universe might be far more alive, far more intelligent than we've ever dared to believe. And here's where it becomes deeply personal. Because every discovery Webb makes doesn't just expand our knowledge, it shrinks our certainty. We used to think the laws of physics were unshakable. We used to think we knew how the universe worked. But now we're reminded of something far more humbling. We don't know as much as we thought. The universe is bigger, stranger, and more mysterious than our wildest dreams. And that's the climax. That's the moment where awe meets fear, where wonder meets humility. But here's the comfort. You are part of this mystery. Every atom in your body is tuned to the same rules that govern galaxies. The iron in your blood was born in a star that lived and died billions of years ago. The very thoughts you're having right now are powered by the same physics that fuels suns and black holes. So when Webb shatters our understanding, it isn't showing us that we're small. It's showing us that we're connected to something vast beyond comprehension. As you drift deeper into rest, think of this. The James Webb Telescope is still out there right now, silent, watching, catching the oldest light in existence. And each photon it captures is like a secret, arriving late to the party, carrying a message from the dawn of everything. One day, those secrets may reveal the ultimate truth. Until then, we wait, we dream, and we listen. So here we are, at the edge of everything we know. The James Webb Space Telescope has shown us beauty beyond imagination. It's revealed galaxies that shouldn't exist, black holes that defy logic, and whispers of cosmic patterns that suggest the universe is far stranger than we ever dreamed. But instead of answers, Webb has given us better questions. And maybe that's the point. Maybe the universe was never meant to be fully solved, like a puzzle with a neat ending. Maybe it was meant to be lived, wondered at, and felt deep in our bones. Think about it. When you look up at the night sky, you are seeing history. Some of that light has traveled for billions of years just to reach your eyes tonight. You are part of its journey, a witness to something both fragile and eternal. And while scientists debate equations and theories, what matters most is this. The universe is alive with mystery, and you are inside it. You're not separate from the cosmos. You are the cosmos. Given shape, given thought, given the gift to ask why. That, to me, is the most beautiful secret Webb has given us. Not just that the universe is vast, or ancient, or strange, but that it's deeply connected to us. Every discovery out there is also a discovery in here, inside you. So as you close your eyes tonight, let yourself drift with that thought. The stars above are the same stars within. And maybe, just maybe, the secrets Webb has uncovered aren't about physics being broken. Maybe they're about us finally learning how infinite we truly are. And before you fall fully into sleep, let me leave you with this. There are more secrets out there, stranger ones, deeper ones. And in the next video, we'll open those doors together. So if you haven't already, subscribe. Stay curious, and when you're ready, let the next story carry you even further. Good night.